Hi guys, so just to clarify some things on graphing with transformations homework, what am I looking for? I'm going to do these because your two exam problems are like these sections on the worksheet. These are the two problems that are on your test. I'm going to do it like what I'm looking for on the test, okay? So I've seen some people turning this in right, the few that have turned it in, some people turning it in not showing any steps. So that's problematic because the whole point is we're looking at the steps of the transformation. So let's do one section of each. So for number one, for section one, we'll just do number one, and the directions say for this worksheet, you will have to watch the graphing of transformations video and follow the template shown. So I'm going to use the template that I show in that video that I do. Let's switch over to my tablet. Okay, let's graph this one. Now this is the transformed function. You can tell because it doesn't look like one of our parent function. Okay, so that's the transform function. For this kind of problem, because it says graph using transformations, we actually have to come up with the parent function. So the parent function for this would be f of x equals, so let's delete the a, b, h, k. Deleting the a is -2, deleting the b, there's none, deleting the h is -1, deleting the k is -4. That means that we are deleting everything but x squared. So our parent function is x squared. Okay, now writing down the a, b, h, k. These are all things that I ask for on the test. The a value is -2, the b value is 1, the h value, it's 1, but this is a right shift. Okay, I don't care if you guys write -1 if that makes sense to you, but personally, I like left, right, up, down. It makes more sense. And the k is for down. Okay, so then moving on. Let's do our steps of the transformation. We're going to start with points on our parent function. Our parent function is x squared. So the points on our parent for a parabola, I recommend keeping track of the vertex for sure, and also 1 point to the left and 1 point to the right. So let's keep track of x equals -1, 0, 1. And the points on the parent, I'm plugging into the y equals x squared function. So that would be 1, 0, and 1. Okay, now these are points on the parent, and we're going to track the transformations. So this is like where all the credit that you're getting for this problem is coming from. It's not really just the graph at the end. It's specifically showing me these steps, because these steps are important for calculus, almost more so than the graphs, if that makes sense. Okay, so now moving on, we do h first, the order h, b, a, k. This is the order of the transformations. So h, b, a, k is our order. So for h, let me move that a little bit. For h, this was a right shift, so it's going to be all the x coordinates plus 1 unit. So it'll be 0, 1, 2, and the y coordinates stay unchanged. My b value is 1, so there really was no b transformation here. Okay, so then the next step we're going to do is going to end up being our a transformation. And for the a, we do y times our a value. So my y's are going to change to 2, 0, 2, and my x's stay the same. Okay, and then for k, we're going y minus 4 because we have a downshift. So in terms of plus and minus, personally, I just like to think about the geometry. We all know what shifting something to the left, right, up, and down looks like on a graph. And it's not, I'm just thinking about the picture. Like if I shift down, the y units should get smaller. Okay, so subtracting 4 gives me -2, -4, -2, and the x's stay the same. Okay, so we made it all the way through the HBAK. That means that this is going to be what gives us our graph of g of x. Okay, so for the very last step, give me a sketch of your points. And the points would be 0, -2, and 1, -4, and 2, -2, and connecting them. There we go. There's our transform function. Oh, yikes. Okay, so this is actually good because this is something that we should do at the end. What happened? Let's take a look at this step here. I actually made a mistake, huh? Because I didn't multiply by -2. I multiplied by +2. So that's actually going to change. I could edit this mistake out. I'm not going to, though. We'll just fix it. I didn't multiply my y units by -2. So I made a mistake. Okay, so when I subtract 4, I should get -6, -4, -6. You guys see the difference? And I could tell that looking at the graph because I was like, wait, there should have been a reflection. I should have had to reflect this across the x-axis, but this is an upward-facing parabola, right? So that's how I caught my mistake on that one. So 0, -6, -1, 2, 3, 4, 5, 6, 1, -1, 2, 3, 4, 2, -1, 2, 3, 4, 5, 6. There we go. I think that looks a little better. Perfect. Okay, if you don't label the scale for me, it's not great because I don't really know what you were going for, so please label the scale and then we're good. Okay, so let's do an example of a part 2 problem. Okay, so for part 2, still graphing with transformations, but just a different style. So for number 2, what we're going to keep track of is the points on our parent. Instead of having a formula that we have to plug into to get them, we already have them. So I'm just going to write down the points that are probably the easiest to see, the bolded out points. Looks like the coordinates are -2, +4, 0, or sorry, pardon, -1, 2, 2, 2, and 4, 0. Those are my x and y's. Okay, and then let's do for number 1. The function we're trying to graph is f of -x + 1. That's going to be our transformed function. Okay, so just to reiterate, this picture here, that is our parent. We don't have to figure out the parent because it's given already. So some of the work from part 1 is done for us. And for the ABHK, we can see them hopefully a little bit easier with this format, but you know, it's kind of the same idea. So it was -x. Okay. So we were trying to do f of -x + 1. So let's identify our A, B, H, and K. So our A value is 1, nothing. Our B value is -1. Our H value would be here if it was there, but it's not, so nothing. We've had no shift left or right, and we've had 1 shift up. So really, the only things that have been done are the B and the K. Okay, so when I go to track my t-chart, let me move this down a little bit. The H step we get to skip. The first thing we're going to do is the B value. And to do the B value, it's x divided by B, so it'll be x divided by -1. We'll take all the x coordinates, divide them by -1, we get 2, 1, -2, 4. The y coordinates 4, 2, 2, 0 stay the same. And then to do the K, the y coordinates, it's a shift up, so we'll add the 1 unit. And we get 5, 3, 3, 0. The x stays the same. Okay. So just checking over our work. We added 1. Gotta be careful. There we go. After last one, I'm gun shy. I'm sorry, I'm in a little bit of a rush now because I have an appointment very soon. So I have a little bit of like scramble brain going on here. Looks good though. X got divided by -1, okay, and then we added 1 to the y's. So now we're ready to graph. Okay, so 2, 1, -2, so 2, 5, 1, 2, 3, 4, 5, 1, 3, -2, 3, -3, 1. Okay, so there we go. And it looks like the same kind of shape as the last one, just with obviously the transformations applied. So what to be on the lookout for. How I grade these on your exam, I am looking for the following things. I am looking for pretty much everything here. I'll be asking you for ABHK. I ask you for these T-charts. This is like the bulk of the points is the T-charts, because this is where I tell whether you know the steps of the transformation. Okay, so what I can see sometimes that's like, don't do this, I'll write that. Don't do this. Okay, this is bad news bears. Okay, what people will do is they'll sometimes eyeball the formula and they'll just say, it looks like it got left shifted 1 and up shifted 2, and there's maybe a vertical scale. And so it maybe looks a little bit like, you know, like that or something. And they'll just kind of wing it. Okay, this kind of sketch isn't what I'm looking for because it really doesn't reflect each step of the transformation. Like I said, we need to actually track them individually and exactly, and the number of points that we're tracking is kind of important. So please don't just jump to the picture. It's the actual work is very important. So if you're someone that didn't do this on the homework, we definitely still have some time for you to go back in and maybe fix some of those up. And the main thing, honestly, is that everyone does it right on the test. So on the homework, if you don't practice it, the concern is that you won't do it right on the test. That's the whole thing that I'm concerned about. So anyhow, this is how to do that worksheet. And hopefully this was helpful. Just one quick note about how to submit it. This is submitted on Gradescope. So this will be your first practice at submitting homework on Gradescope. It'll prompt you to take a picture of every problem if you choose picture. If you choose PDF, then you just upload one PDF file. So it's your preference. Do you want to make a PDF in advance and then upload it? Or do you want to take a picture of each problem? It's fine with me, either one, any way that you can get it into Gradescope. So hopefully that was helpful.